Good morning, students. I'm Sunanda Jana, Assistant Professor, Haldia Institute of Technology. Today, I will discuss the topic flow and error control. Now, at the end of discussion, what you will learn from this topic? You will learn that during data communication, how to control flow of information, and if error occurred, how to control that. And this flow and error control information for performing that, which layer is responsible and how it is doing that. As in the previous classes, we have already discussed that during data communication, we need at least two devices. That means one must be sender and one must be receiver. And sender will send the data and receiver will receive the data. And during communication, we know that how using OSI models of 7 layers that communication performs. That we have already discussed. And also we have discussed what are the responsibilities of different layers and how when sender is sending data through application layers, all it is coming to presentation, session, transport, network, data link layer, and finally it will reach to physical layer. And again from physical layer of the sender device, it will reach to receiver side physical layer. Again all the 7 layers finally it will reach to this application layer and receiver will receive that one. And actually consider that in each and every communications, that communication performed virtually between each and every layer. So that means we are imagining that the sender side's physical layer is communicating with the receiver side's physical layer, sender side's data link layer is communicating with the receiver side's data link layer, and in that way the total communication performs, and finally from sender side data will received by the receiver at the receiver end. As our topic is mainly flow and error control, so first we have to know that which layer is responsible for particularly performing that operation. Today actually we will discuss some data link control operations, and under that flow and error control is there. Now, first we will know, which we have already discussed when we have discussed that OSI models of 7 layers. Again, in brief, I am telling. We know that the responsibilities of data link layers are, first is framing. So that means whenever data comes from another layer, then during transmission, it divide the data into manageable units, and those are called as frame, and the process is called as framing. And it is also responsible for giving the physical addressing. And another two responsibilities of this layer, mainly flow control and error control. And finally, it is also responsible for access control. Now, first, as our topic is mainly based on flow and error control, so we will discuss what is flow control and what is error control, and how the data link layer is handling all those things. Flow control is a word that is whenever sender is sending the data, at that moment, as I have already told, we are having sender device and receiver device. When sender is sending the data to receiver, uh, in each and every case, sender is also having some limited memory size and speed, and receiver is also having some limited memory size and space. And when it is receiving the data, it also may be the less speed of receiving the data. So at that moment, suppose this kind of situation may occur, that sender is sending data in higher speed, but receiver is unable to receive that much of data at that speed. So because of that, there may occur some problem. So here data, when the flow control means how the flow of data from the sender side can be restricted, so that before waiting for the acknowledgement, sender can understand that what is the limit and how much it has to send the data. So that means the definition we can write in this way, that it is a set of procedure that explains sender about how much data or frame it can transfer or transmit before the data overwhelms receiver. Okay. So why exactly we are doing so? I have already told, because receiver, when it will receive the data, it has the receiving or accessing capacity or speed. It is also limited, and as well as it is having the limited memory. So because of that, we always have to understand that the sender side data speed and as well as the receiver side data speed, it is not synchronized. So because of that, the problem may occur. So here the procedures of flow control, it is using to give the restriction to the sender side data flow, so that there should not be any problem during transmission. Now comes to error control. Now, when we will go to the next slide, there we can find out that how error control can be occurred. Now comes to error control. Error control means whenever where a sender is transferring the data, maybe because of transmission media problem or any kind of problem, frame may lost or damaged. So because of that, to suppose how that, then what is our target? That what sender is sending, receiver must get that accurate data without any loss or without any problem. So because of that, whenever sender is sending the data, it is always keeping one copy of the data, so that if any error has occurred in the receiver side, then it will resend or retransmit the data, and in that way it performs error control, and this process is called as ARQ, or it is also called automatic repeat request. Now, as we have already discussed what is flow control and what is error control, now we will discuss that what are the mechanisms data link layer followed to perform those operations. There are actually three mechanisms data link layer follows, or three protocols data link layer used for that purpose. What was those? First one is stop and wait ARQ, then go back in ARQ, and then selective repeat ARQ. And today, in today's class, we will discuss stop and wait ARQ. In case of stop and wait ARQ, first we have to know some those basic things. That means stop and wait ARQ is having certain features. By following that features, it performs its operation. As I have already told, for communication, we required sender device as well as receiver device. So here you can see one sender device and another receiver device is there. Now, when sender device is sending any data, it always keeps one copy of that data during transmission. Okay, this is the first feature of stop and wait ARQ. Though exactly why it is keeping one copy of that data? Because when during transmitting the data, when receiver will receive the data, there may be the chance of data lost or damage. So because of that, if error correction or error control is required, then again it has to resend the data. So because of that, for safety and security purpose, it always keeps one copy of the data. Next important features is that whenever sender is sending data, it will always wait for the acknowledgement. Okay, so here the sender data frames number and acknowledgement number is given. So that means frame and acknowledgement number given to identify that which frame went to send and which acknowledgement went to send. So here the rules we are following that, suppose sender is sending frame number 0. Here actually the numbering done by using only 0 and 1 alternatively. So when we are sending frame number 0, then the receiver will send acknowledgement 1. Why it is so? Because it is informing that the receiver is informing that I have received successfully from 0, and now you send me frame number 1. Now the same thing will happen, though if initially the sender is sending from 0, then next it will send frame 1. And if it is sending frame 1, then receiver will give the acknowledgement as 0. And in that way, the communication will goes on among sender and receiver. Now, here you can see some variables A is in the sender side and R in the receiver side. So what are those variables? In the sender side, it is having one variable, that is sender side variable indicated by S, which keeps the value or the number of the frame it has sent. Okay. And in the receiver side, it is also having the number. So what is that number? Receiver is having that number of the frame it is expecting. So you can see here S equal to 0, so that means sender is sending frame 0. And here R equal to 0 means now receiver is expecting to receive that frame 0. And after receiving the frame, it will send the acknowledgement. And as it has received frame 0, then it is sending the acknowledgement 1, and it is telling that I have received frame 0 and the next frame you have to send is frame 1. And this is the normal operations how stop and wait ARQ works. Now, you may ask another question, that if something problem occur during transmission, this is the smooth communication, but because of transmission media problem or any kind of problem, data loss may occur, data damage may occur. So at that moment, what will happen? In case of stop and wait ARQ, there is no negative acknowledgement, only positive response we can get in this process. So for that reason, what happened here? When a sender will send data, if because of any kind of problem, data lost or damage occur, then sender always has a timer. So that's when data starts the timer, and within the time limit it to always wait for the acknowledgement. If within the time limit it has not received the acknowledgement, then again it will consider that some problem has occurred during transmission, then again it will resend the data frame. So so that means during each and every communication, one time limit also maintained. Now comes to, as we are right now discussing on the stop and wait ARQ, and there are 4 situations we may face. One is normal operation, when there is no any problem, smooth operations between sender and receiver is going on. Next situation it may occur is frame lost. So as I have already told that during transmission, because of transmission media problem or any kind of situation, frame loss may occur. Okay. So here you can find out in this picture frame 0 transferred, and for that acknowledgement 1 received. And here is equal to 1. So that means right now sender is sending frame 1, but it has lost. But receiver value are equal to 1 because it is right now expecting for frame 1. As the frame has lost, you can see here the timer starts when sender is sending its frame. When time out, it will wait up to its time limit. And after that, if the sender will not receive any acknowledgement, then again it will resend the frame. You can see here again it is resending frame 1. And in this way, the frame loss problem can be solved. Now, next comes to the another problem may arise in the case of stop and wait ARQ is lost acknowledgement frame. During transmission of data from sender to receiver, you can find out in this figure frame 0 received by the receiver and acknowledgement 1 also it sent, and it is also received by the sender. Now frame 1 it has sent, frame 1 received by the receiver, but when it sent the acknowledgement 0 lost in the way, then what sender will consider? as I have already told, there is no negative acknowledgement. So send, and also we know that sender has a timer after every during every transmission it starts its timer. So it will here also wait up to the time limit, and when time out, then again sender will resend the frame. Now here you can find out that receiver is now expecting for frame 0 because it has already received 1. So now it will discard which frame? Discard frame 1 because it has already that frame. Okay. So it will discard frame 1, but again it will send acknowledgement 0, and by sending acknowledgement 0 it will inform the sender that I have already received frame 0. Now send me. I have already received frame 1. Now send me. Yes, now send me frame 0. Now comes to the next operation, that is delayed acknowledgement frame. Now, during transmission of data, as we know that because of transmission media problem, acknowledgement delay also may occur. So at that moment, what will happen? You can see in this picture here also it will consider the time limit, and yeah, here you can see frame 0 went and received by the receiver, but for frame 0 the acknowledgement 1 came here, and it is not within the time limit, isn't it? So here again it has resent the frame 0. Then receiver, what it will do? It is right now expecting for frame 1. So it will discard that frame 0 because it has already received frame 0. So it will discard that, and after that again it will send acknowledgement. But when it will receive, it will catch the acknowledgement in the sender side. Sender has already that acknowledgement, so sender will also discard that one, and in between it also send frame 1. Okay, frame 1, and in that way communication will goes on. Now comes to the disadvantages of stop and wait ARQ. Here the mostly what is happening here, sender can only send 1 frame at a time, and receiver can also receive 1 frame at a time. So here means when the time and the number of frames for communication is only 1. Another thing is that there is no any negative acknowledgement. So if in between any frame lost occurred, then again, or delay acknowledgement or anything occurred, then again that communication will goes on. That means again resending of frame and resending of acknowledgement also going on, even if maybe sender has received that frame or receiver has received and that frame, or the sender has received that acknowledgement. Even if those communication will goes on, this is also time consuming. And now to improve the efficiency and to improve the frame numbers, that means how we can send multiple frames, and is there any facility can be provided by which that particular frame which has damaged, that with that frame number any negative acknowledgement can be sent in the sender side, so that sender can send only that frame. Those facilities can improve the performance of the protocol. So to improve those things, the next two protocols are there, that is go back in ARQ and selective repeat ARQ, which we will discuss in the next class. Thank you. If you have any query, you can ask.